Okay, so for today, again, we're on that sort of handout, not in the packet, but that handout that you got from me. And I want to start by talking about number systems. So this is something that you talked about probably in maybe 6th or 7th grade at some point, but didn't spend a whole lot of time on. And it's not something that we spend a lot of time actively talking about, even though we're working within these different number systems on a daily basis. Up to this point, we've lived in what are called the real numbers. So any number that you have seen in my class or in Algebra 1 or in geometry or anywhere else up to this point has been what we've called a real number. And then real numbers we split into two categories, rational numbers and irrational numbers. Irrational numbers are numbers like pi, okay, or square root of 2. Non-repeating, non-terminating decimals, okay, those are irrational numbers. Rational numbers are numbers that we could express as a fraction. So 2/3. I could type this in my calculator and get a decimal that would go on forever, but it's a repeating decimal because I can express it as a fraction instead, okay? 1/7 would be a rational number. Inside of the rational numbers are numbers that we call integers. So these would be positive and negative numbers, right? And then we can, so 5, negative 125, those are all integers. And then we can break this down further. We could talk about whole numbers, which would be just the positives, right? So 2 would go in here and 5 would go in here, 0 would go in here. And then there's an even smaller category called natural numbers that are everything but 0 from the whole numbers. So we have all these different sort of classifications for numbers. Natural numbers you can think about as numbers that you could count on your fingers and toes. Whole numbers add in 0. Integers add in the negatives. Rational numbers add in the fractions. Irrational numbers would be those non-repeating, non-terminating decimals, but they're all part of this real number system. Okay, real numbers are actually not the biggest sort of category that we have for numbers. We actually have a bigger category that includes the real numbers called the complex numbers. Complex numbers include real numbers, but they also include imaginary numbers. And that's what we're going to talk about today. Okay. And in some cases, there is some overlap between these two, which falls out here in the sort of just complex number area, not just a real number, not just an imaginary number, but imaginary numbers and complex numbers are what we're going to see today. Okay. So on that handout, when we talk about imaginary and complex numbers, they come from some problems that we did see in Algebra 1 and something that we kind of started to talk about yesterday. So we're going to start by simplifying some square roots. Square root of 16 is? Thank you. Square root of 16 is 4. Why is the square root of 16 4? Because 4 times 4 is 16, right? How about square root of 18? Does it have a nice square root? No, but we can still reduce it. I can find factors of 18, right? What did we say? What times what gives me 18? 9 times 2 would do it, or 3 times 6, that's fine. And then 9 would be 3 times 3. And so what I want is a pair of factors, like we had with our 4 times 4. We have that with our 3 times 3. So if I get a pair of factors, I get to pull that out of the root. Whatever doesn't have a partner stays inside the root. How about 54? Does that have a nice square root? Not so much. So we can simplify it. You guys have seen this before. So what times what would give me 54? 9 and 6 would do it. And then we keep breaking these down. 9 is 3 times 3. 6 is 3 times 2. and I'm just looking for a pair. And they don't have to come from the same number. So I could pair this 3 from the 6 with the 3 from the 9. The idea is that I get a pair. As soon as I have a pair, I can pull that number out. Whatever's left stays under the root. So 3 and 2 stay under the root, multiply them back together, and I get 6. If I had multiple things that came out of the root, I would multiply them together too. Now let's take a look at our last one here, square root of negative 16. We want to say it's something to do with 4, right? Because the square root of 16 is 4. I had some people throw out negative 4. The trouble with that is that if the square root is negative 4, that means negative 4 times negative 4, right? Which is still just positive 16. So we're kind of in a pickle with this one. And we did see this a couple times in Algebra 1, and I told you for Algebra 1, for right now, we're just going to say that there's not a real solution, and we'll kick that problem down the road to Algebra 2. Now it's our problem that we have to deal with. So this negative is what's causing me grief. This negative, right, that negative inside the square root, is where we define imaginary numbers, okay? So imaginary numbers are represented by a little I, a little lowercase I, and we define I as being the square root of negative 1. So for this square root of 16 guy, we could actually represent this as the square root of negative 1 times the square root of 16. So we can sort of separate that out so it fits my definition. We're primarily going to use i's when we want to simplify the square root of a negative number. That will be our main use for I in Algebra 2. There are other applications of I in some advanced sort of contexts. We're going to focus on I is going to be defined as the square root of negative 1, and we're going to use it when we're solving for solutions for polynomials when we don't have a real solution, okay? Often this will show up as the square root of a negative number. So with this in mind, I want to talk about simplifying some of these things. So let's take a look at our square root of negative 16. If I split it up like this, what's the square root of 16? 4. And then how did we define the square root of negative 1? We said that that's I, right? So this would simplify to 4i. 4 when I take the square root of 16, and I, since I'm taking the square root of a negative. So if I hop down to example 1 here, I've got the square root of negative 2. Since I'm taking the square root of a negative, I know it's got to be imaginary. I know it's going to be an I. And then let's think about the square root of 2. Can I simplify that at all? No, 2 is prime, right? Its only factors are 1 and itself. So I can't actually simplify the square root of 2 anymore. So this would just be I root 2. That's the only simplifying I can do. If I take a look at my next example, because it's got a negative, taking the square root of a negative, I know it'll be something with an I. Can we simplify the square root of 4? It's 2. So the square root of 4 is equal to 2. The square root of a negative number is going to be imaginary. So we get 2i here. 2i. For our next one, we've got the square root of negative 24. So we know we're going to get something imaginary. And then does 24 have a nice square root? Not so much, but we can simplify that. What times what gives me 24? 6 and 4 will work. 6 is 2 times 3. 4 is 2 times 2. Remember, we're just looking for a pair here. So I've got a 2 that I can pull out. I also will have this I hanging out in front. And then stuck inside my root would be this 2 and 3. Multiply them back together to get 6. We've simplified roots before. We did this in Algebra 1. We just didn't do it with negative numbers. Okay, so if you're simplifying the root of a negative, you're going to have an I in your simplified form. For our final example here, square root of negative 15. Square root of negative 15. Since I'm taking the square root of a negative, That means I'll have an I. And then does 15 have a nice square root? No. And then if I wanted to simplify 15, what times what gives me 15? 5 and 3. Any pairs there? Nope. And I can't break these down anymore. So this would just be I root 15. There's one more big idea we need for I, and it's what happens when we square I. So remember that we just defined I to be the square root of -1. So if we have I squared, which we will see on occasion when we do some distribution, when we see I squared, remember that's like taking the square root of -1 squared. What happens when I square a square root? Yeah, they sort of undo each other. And so I squared is just equal to -1. That will be important for some of our simplifying. I squared is equal to -1. So everything that we've looked at so far on this page has been an imaginary number. We've lived in this box here. Now I want to talk about this broader category of complex numbers. So when I've got this sort of link between imaginary and real numbers, okay? Complex numbers have both a real component and an imaginary component. So it's got both things going on, okay? We write it in the form A plus BI. And all that means is that our sort of standard form, if we want to call it that, for complex numbers is that we put the real part first, the imaginary part second. Okay, real part first, imaginary part second. So A is the real part of this number, BI is the imaginary part of this number. Okay. So the last thing I want to do with you is talk about where each of these would fall in our number system for these examples down at the bottom. Okay. So we're going to state if something is real, imaginary, or complex. For complex numbers, we will underline the real component and circle the imaginary component. Okay. So 7. Have you seen this number before today? 7? I hope you've seen a number 7 before today, right? Yeah. Nope, never seen a 7. Didn't know what that character was. No. 7 you've seen before today, right? So it's a real number. It would live in this box. Specifically, it'd live in this box, but it would be in the real numbers. How about 4 plus 2i? Have you seen a number like this before today? No. Okay, so that means it's got to be either real or complex. Since it's got a real part and an imaginary part, that makes this a complex number. My real component would be 4. My imaginary component is 2i. The imaginary part's easy to spot because it's got the I. How about this guy? Real, imaginary, or complex? Complex. It's got a real component and an imaginary component. That makes it complex. And then at the end here, I have I root 6. This is imaginary. It only has an imaginary part, right? The I is attached to the root 6. That makes this imaginary. Questions for me? Okay. So here's what you are going to work on for the rest of our class time, and you'll probably have to finish up this homework tonight. In your packet on page 4, there's a list of assignments that we're going to look at in a little bit tomorrow. I think we'll work on these. That'll give us some practice working with imaginary and complex numbers. But for today, you have the video lessons on Khan assigned to you. No practice sets for today, just the videos to watch, okay? Rather than making a video myself, because these already exist and are available to you, this is your notes for tonight. You have a couple of videos to watch on Khan Academy, okay? They're not on Delta Math, they're on Khan Academy. And as you watch, you're going to take notes on this page, okay? Some of this stuff are things that we've already gone over together. So some of this you could probably fill in even without having to go through those videos. But I want you to watch those videos because he's going to go through some examples for the same types of problems I'm going to ask you to do tomorrow, okay? So again, these are on Khan Academy, okay? And they go with your notes on page 4. Tomorrow, again, we're going to do some more practice with our complex and imaginary numbers. I do want you to pay special attention in the video where he talks about classifying complex numbers. For Khan, I believe that they ask you to categorize everything as a complex number. And then additionally, if it's only real, you would say that it's real. If it's only imaginary, you would say that it's imaginary. That's a little bit different than what I would ask you to do in class. So make sure you pay special attention to that on your video.